Welcome all back. Thank you very much for the participation on this school. And we will start with the last session of workshop exercises with Cristina. Cristina, thank you very much, and the space is yours.
Thank you, Esteban. Then yes, this is the last day of the workshop. I'm gonna share my screen. Well, before that, I will just say again that during this week we have been working on the measurement of clustering using a simulated galaxy catalog. But today we're gonna see what is more what we have to face in the real life. Then we will be working with an image. We will not be measuring clustering again of anything, but I just want to show you how can you generate random catalogs in the real life. Then today we will just generate a random catalog, but we will not measure the clustering. Okay. I guess all of you already received the instructions for the workshop today, but I'm gonna open this here. Okay, so why this is important to make? Because as you saw in the simulated catalog, when we generate random positions, that was pretty fast and easy to make because we had basically a nice angular selection function. Then we had like a square region, very well defined, in which we had to generate random sources. Then to be more specific, maybe I can show you this again. This is from the workshop number 1. We had this kind of distribution, sky distribution for the galaxies. Then we have like a complete coverage over this square region. Then to generate a random catalog, we just had to generate random points over those between 0 and 1.5 in 1.4 in one of the each coordinates, and that was everything. Then today I'm gonna show you how can we actually generate random catalog when we have real observations. And for that, we will be using an image, which is an image of a quasar field. This is one of the images that I show you in the lecture today in your morning. It's a study of 17 quasar fields, a redshift 4. We imaged those fields to just look for galaxies around the quasars. Then this is real images taken from BLT. Then before to start, actually, I want to show you this, some examples, because I explain you a little bit here that normally when we have images, in this case, we will be working with optical images. We always are affected by some defects in the image or by some bright star in the image that don't allow us to perform an accurate photometry on those areas. Then what we usually do for those cases is that we just mask the areas that are not useful for science, and then we just don't use that areas. But that means that when we create the random catalog, as I mentioned in lecture 1, in lecture 2, we have to really mimic exactly the geometry of the survey. Then if we have some masked areas in the image, we also have to consider those areas for the random for the creation of the random catalog. Then I will start showing some just examples of what could we have in real observations. Then here I'm using DS9 to open an image. I guess all of you are familiar with DS9. Otherwise, let me know in the chat, then I can provide more details. But for example, this is one of the image that we got. Our quasar is just here in the center, is this bright object that you can see here. But unfortunately, we had a very, very bright star just in the edge of our image. Then that made all these features here that you can see, then all the flags of this bright star is contaminating the flags in this part of the image. And also we have here like a very bad part that we cannot use to detect galaxies. Then what we had to do is just to mask all this region in which the photometry is not reliable, because we will not detect galaxies over that area. You can also always play with the scale here to really check what are the regions that are not useful. Then another example, I have here another example. In this case, is less extreme, but for example, here we have a bright star that also is contaminating the neighborhood. Then maybe I can zoom in a little bit to show you this better. Then here we have, well, two stars actually. Then if we will have a galaxy over all this region in the sky, for example, we will not be able to detect that galaxy just because this star is contaminating all the area and we cannot really observe sources in that area. Then in this case, I will maybe show you here. In this case, we have to mask all this area that I'm gonna show you with this circle. We just have to mask all this area and just not use it for our study. And we can actually do the same for this star, which also looks very bright and is contaminating this area here. Then that is just to show you some examples of what we normally have, what is the situation that we normally have with real observations. Then now I would like you to download the image that we will use today. You can download this from this address here. Oops, right. From this address, this is just an image of one field, again, of our quasar Redshift 4, taken with VLT in the band R. Then I hope you can download this in real time, because I would like to make this part together with you, but it is this image here. Then I would like you to open the image in DS9 and check the information in the header, just to start. I know that you were, or some of you were working also with DS9 images with Aurora last week. Then I guess you are familiar with DS9 and with the header of images in general. Okay. Okay, then this is the image that I put in the web page. Then I just open it with DS9. And here we can always see the header in DS9. Then the header of this image contains a lot of different information. Probably the most important information is these two parameters. Maybe, I guess this is too small. I'm gonna check if I can maybe increase the size. No. Font. I don't know if, yes, great. Okay, then this is the header, and probably the more important parameters in the header for clustering purpose are these two numbers. This is just the number of pixels that we have across the x-axis and across the y-axis, then 1576 and 1622. You can easily check that this information is correct just by putting your pointer in the very end of the y-axis. Then you can check in this part here, you can check always the x and y position in pixels, and you always can check here, well, where you have physical, you can check the coordinates. Oh, no, sorry, no, we're here in WCS, you can check the coordinates of the pixel in which your pointer is situated. Then here, if you put here in the last pixel, you can see that in the x-axis we have 1526 pixels, and in y-axis we have to go here. We have, I see 1619 pixels more or less. Then that is the information that we have in the header here in these two variables. Then all this part is just like some typical information of all the images. And then we have here this part here is defining how you convert from pixels to coordinated, right? Because here, this is the position of the central pixel in your image, the X position, and the Y position is here. Then these CR val and CR peaks are the variables that indicate the central position in the middle of the image in pixels and in coordinated. Then this is ray ascension and declination. Then those are the important values for the image. And also there is like more information to translate from pixels to coordinated that are, I think, are contained in some of these parameters, CD1 and CD2. And normally, I think, this is just extra information, not so important, but this is the information that we are more interested in this case. And I think, I think that is all what we care at this point. Okay, so that was the header of the image. And now I'm asking you to check the image and identify some regions that you think the photometry is not reliable. Then I already showed you some examples in which we had like bright stars or shades or other defect of the imaging. Then we have to mask those regions. Then I'm asking you to check this image, play with the scale, and try to decide which part of the image is not very reliable for photometry. Then I will leave you for, 5 or 10 minutes only, just for you to download the image and check the image, play with the scale, and check and think what region is not reliable. And I'm gonna be back in 5 more minutes only, because I think that is something very quickly to check, but I want you to download the images and everything. Then I will be back in 5 more minutes. Okay, I hope that all of you download the image that we are using. Okay, so this is our image, and here in DS9 you can always play with the grayscale to check better the image. Another feature of DS9, which is also nice to check in which part the photometry is not working pretty well, is to make a smooth of the image. Then here in analysis, you can select smooth.
Hi, Christina.
Yeah.
I do have a question, but it's not in the chat. Maybe you mentioned it, but I just missed it. You have this circular region in that image, in the bottom of the image.
Yes.
What is that an artifact of the camera, or what is that?
That is an artifact. We never could figure out why we had this artifact, but it's probably like a shade when the images were taken. For some reason, there is a shape here, a shade which is also repeated in some of our other images, but we don't really know what is the origin of this. But it's just instrumental. It's nothing astronomical.
No, yeah, I was not expecting was astronomical, and if it will be, I will be extremely surprised. But yeah, I was very curious about it, because if it's instrumental, it means that every single image from this camera will have the same issue. And how do you correct for that?
It actually several images had this issue. I think that one of the day in which the images were observed, in which the fields were observed, something was wrong with the instrument, and they had this pattern in all the images observed that day. But for the images that they were observed, giving us for observed the other days, we didn't see this pattern anymore. Then I guess it's something that happened in the telescope, or I don't know, but it's not repeated for all the rest of the observations. It's only in like some few images.
Okay.
And yeah, this is strange, and in this case it's very unfortunate, because we are losing all this area. We cannot really trust on the photometry in this area.
Exactly.
Then in this case, what we did is just to mask this area and not use it.
Okay, thanks, Christina.
Yeah, no problem. Okay, then with this smoothing of the image, you can really see that this part is not like a very reliable for the photometry. Then what we did was just to mask this image and not use it. Then I put a mask image in my web page too, that you have to download. Is this 1130A mask that fits. I'm gonna open this image here. Where you are. Here. This one. Okay. Then this is a mask. Maybe, yeah. This is just an image that contains values 1. You can see here in this part the value of each pixel. Then if you move the pointer in this part, you have only value 1. And here in this part, you have value 0. Then I just did this by hand just to show the idea for this workshop. In the real life, you try to define better the region to be masked. But the idea is that we mask all this region. We are not using this for science. Then all the pixels in this part has value 0. And if you actually, you can blink the images to check. I will just match the frames. and blink the images, then you can see that we are masking all the part here. Okay, so that means that we just were able to look for galaxies in the rest of the area, in the area in which we have here values equal than 1. So, yeah, that is what I'm explaining here. Then now we need to create a random catalog with sources randomly distributed over the effective area that we use to detect galaxies. Then that is the region with value 1 over in our mask image. Then how will you create a random catalog in this case? And I would like you to think a little bit about this. I don't want to give you the answer right away. Then maybe I'm going to give you just 5 minutes. Then you can think what is the procedure that we could follow to really make this right. In the meantime, maybe you can also try to open the image using Python or any other language, because we will create a random catalog and then we need to open the image now. Then I will go again for only 5 minutes and be back here. And hopefully you had time to think about how to create a random catalog in this case. Okay, I'm back again. Then I hope you could think on some ideas. If not, I'm going to give you the answer now. I don't see any question there. Okay, so the way that, well, there are several ways to solve this problem, but one easy way to make this is just to generate random points over the entire image here. Then that is exactly what we did for the workshop 2. We need to define just the minimum and maximum coordinated values and generate random points over that area. In this case, you have, well, in this case it's easy actually, because we have like a nice square area on the sky, but sometimes in reality, sometimes the images also have like weird edges here. Then you don't have always like this square region. Then in this case, in this sense, this is an easy one. But here you can check just the minimum and maximum value of the coordinates. I will do this later to show you, but just to explain the whole procedure. For each point that you generate over the image, you can imagine that you are generating points over this image actually, which is the mask. I'm gonna invert a little bit the colors. Okay. Then if you generate random points here, you need, for each random point, you need to check if your random point is located on this mask region or not. And to do that, you have to open the mask image in Python, and you have to store all the data in a 2D array. Then when you generate the coordinates, you have to check in which pixel you are located, which is the transformation between your coordinate and your pixel. And then you can check if the pixel has a value equal to 1 or equal to 0. Then you basically only keep random sources that has value equal to 1. If you have one source with value equal than 0, then you have to generate again the random value, because we always want to generate a certain fixed number of random sources. Note that also this is not the case in this image, but normally we also could have mask regions here in the edge. I mean, sometimes you have an image and you have the region in which you will work, but you also have more part of the image extending toward the edges. Then in that case, you also have to mask and define well what will be the area in which you will work. And in that case, you always also can use a mask and put value equal to 0 to delimitate the space in which you are working, the area in which you are working. Okay, then the first step then is to define the minimum and maximum ray ascension and declination in the image. Then a very easy way to do this, because unfortunately in the header, you only have the central coordinates for the central point of the image. Then you don't have the maximum and minimum coordinated. Then one easy way to do this is just to look at this image in DS9, and you can check, for example, the 4 corners. You can put these regions in the 4 corners and just check what are the coordinates, more or less, because also the ray ascension and declination are not Cartesian. Then you always have to go a little bit more farther than the edge of the image and check what is really the maximum and the minimum value that you have over your image. Then, for example, if you locate your pointer here, you can make double click over the circle. In case you don't know how to add regions in DS9, I just put here in edit, and you have to press region. and then you can put regions just by clicking over the image. Okay, so in this region, for example, if I make a double click over it, I get this information. This is a circle. It is the shape of the region that I have, and the central coordinates for these circles are shown here, and also the radius of the circle in degrees. You always can change the units to what you want. Then in our case, as we did in workshop number 2, I normally generate my random points in degrees. Then I'm gonna just ask DS9 to show me the numbers in degrees, and you can select this here from this menu. Then those are the coordinates in degrees for this point. Then if you make the same for the 4 corners, then you can get the minimum and maximum values, more or less, that you are covering in your image. Then with those minimum and maximum points, you can use what we did in workshop number 2 to create a random catalog. Yes, you can actually find this part of the code in my webpage also, but I guess that most of you could make the random catalog in the second workshop. And then you can just copy, you can remember that we defined the minimum and maximum. In that case, we had that the coordinates were from 0 to 1.4 in both directions, and you just generated random points using any random generator that you prefer. Then that is the first step, and I will leave you to check the maximum and minimum coordinates and create your random catalogs now. I'm gonna give you 10 minutes, I think. Then you have time to check everything, and then we will continue with the generation of points. If you have questions, let me know also at any time. Okay, we have 2 minutes only before the break. Then I will just quickly show what I have done so far. This is just same that we did for the previous workshop. Then I'm not providing so many details now, but I just wanted to show you. Here I just put the maximum and minimum values that I read from the image. Then this is more or less the edges of our image. And I just generate the random numbers. I just copy this from the previous workshop, from workshop 2, workshop 2. And also here you can see that for Python, this is the function that you have to use, numpy random uniform. Then I'm gonna just plot this. This is just a random catalog. We are not using the mask yet, but it's just to show you. And I'm gonna put this code here to plot the coordinates. I will define the ranges. X range and Y range. Then this should just show a square region with random points, as we did for the workshop number 2. Then let's check. Yeah, that is what I have so far. Then just random points over the area that I defined. Then that is what we have so far. And then after the break, we will continue working on this, but we are gonna to consider now the mask. And for that, we will, well, I can explain more detail after the break, but basically we will create a cycle 4, and we will generate each individual number within the cycle 4. And then we can go checking what is the position, what is the value of the mask in that position of the pixel. Then I will show you this at the after the break. Then I will stop sharing here, and I hopefully you can generate your basic random catalog in the meantime.
Thank you, Christina. So yes, we expect that all of you do the exercise in these 15 minutes that we have for the break. And then when we return, she will continue with the last part of the session of today. And after that, we will have the closing of the school. Thank you very much, and see you in 15 minutes.
See you.